So in this video, I'm trying to compute this integral. Oh, okay. And the reason is that this is very famous, and I already encountered so many times. Okay, so in this video, I will just use the standard integral technique, and I will use anything. I will not use the thing called gamma function. But if you're interested in the gamma function, then you can go to my channel and type the gamma function and search for the list that you want to there. So now n is a positive, n is an integer, and it can be the integer from 0 to 1 or 2 something, and then we need to calculate this. Okay, so the idea is that we start from the n equal to 0, we get the special Gauss, the famous Gauss integral, and then we let a greater than a is a positive real number, and then we take a square ax equals to y, right? So we have this, and then we change it. So somehow we can derive this orange formula. So the result is that square root of pi divided by 2a to the negative 1 divided by 2. So if we differentiation respect to a once, then we get this, right? Because with respect to a, then we get negative x squared, and then we get the we get a negative half here, and then this becomes negative 3 over 2. So after did it this minus sign, then we get this. Right, so you see, if I let a equals to 1, then you get the square root of pi divided by 4, which is a generalization of this, right? A special type of n equals to 1. Okay, so if you differentiate second, then you get this one. Okay, so the proof idea is that just this, right? So we starting from this equation, and then we differentiation both n times respect to a. Right, so if we differentiate respect to a for n times, then it will pull out this minus x squared to power n. And also for this one, right, then with respect to a, then it will give us that this term. So the natural then minus 1 to the power n will cancel, and then there will be a half 3 to 5, right? Because this becomes this, so you will take the exponent. So we have 1 divided by 2, 3 divided by 2, 5 divided by 2, up to 2 n minus 2 divided by 2, and then this one will become minus n, right? And then we let a equals to 1, so a cancel. So we have this equals to the square root of pi. So total we have 2 to the n in the numerator, and the denominator, and for the numerator we get 1 times 3 times 5 times 2 up to 2 n minus 1. And then we times 2 for 6 2n, 2 for 6 2n is from the denominator and numerator. So the numerator combined will be 2n factorial, and the denominator will be 2 to n factorial times 2 to n. Come from his, right? Because we can change it into 2 to the n times 1, 2, 3 up to n, right? So we get this. And combine, so combine all of these two, we get 1 over 2n plus 1. And the 2n factorial square root of pi. Okay, so this is the final answer. So if we can check, right? So if n equals to 0, then we get square root of pi divided by 2. Okay, so which is just the generalization of this simple formula. Okay, and because I have so many times about this integral, okay, so I just want to make a video and give the exact proof here. Okay, and I will see you guys in the next video. Be sure to subscribe to my channel if you learned something. Thanks.